Our sun is a star. It's a giant ball of hot gas. The sun is the center of our solar system. It's incredibly powerful. The sun releases huge bursts of energy called solar flares. These flares can disrupt our technology. The sun also has dark spots called sunspots. Sunspots are cooler areas on the sun's surface. They are caused by the sun's magnetic field. The sun is a fascinating and complex object. Studying the sun helps us understand our place in the universe. It's a reminder of the vastness of space and the power of the forces at work in the cosmos.
Billions of years ago, our sun was just a cloud of gas and dust floating aimlessly in the vast expanse of space. This cloud, known as a nebula, was a mixture of hydrogen, helium, and other trace elements. This cloud was enormous and extremely cold, drifting silently through the cosmos. Then, something extraordinary occurred. A nearby star reached the end of its life and exploded in a spectacular supernova. The supernova explosion sent powerful shockwaves rippling through space, traveling vast distances. These shockwaves collided with the cloud of gas and dust, compressing it and causing it to become unstable. Under the immense pressure, the cloud began to collapse in on itself, pulled together by the force of gravity. As it collapsed, the cloud grew smaller and denser, its particles drawing closer together. The collapsing cloud started to spin faster and faster, much like a figure skater pulling in their arms to spin more quickly. This spinning motion caused the cloud to flatten into a disk shape, known as a protoplanetary disk. At the center of this disk, material began to clump together, forming a dense core. This core grew increasingly hot and dense as more material was pulled in by gravity. Eventually, the pressure and heat at the core became so intense that nuclear fusion ignited, a process where hydrogen atoms fused to form helium. This fusion process released a tremendous amount of energy, lighting up the core. With this release of energy, our sun was born, shining brightly and providing the energy necessary for life on Earth.
Deep inside the sun, something incredible is happening. It's called nuclear fusion. Fusion is the process that powers the sun. It's like a giant furnace. In the sun's core, hydrogen atoms are under immense pressure. They are also incredibly hot. Under these extreme conditions, the hydrogen atoms collide. They fuse together to form helium. This fusion process releases an incredible amount of energy. This energy travels outward from the sun's core. It eventually escapes into space as light and heat. This energy is what makes the sun shine. It's what warms our planet, and it's what makes life on Earth possible.
The sun's influence on weather and climate. The sun's energy has a profound impact on Earth's weather and climate. It is the primary source of energy that drives the complex systems of our planet. The sun's rays heat the Earth's surface unevenly, creating a variety of climates and weather patterns. This uneven heating is due to several factors, including the Earth's shape and its rotation. One major factor is the Earth's axial tilt. The tilt causes different parts of the Earth to receive varying amounts of sunlight throughout the year, leading to the changing seasons. The equator receives more direct sunlight than the poles, resulting in consistently warmer temperatures and a tropical climate. This uneven heating creates temperature differences across the globe, which are crucial in forming different climate zones, from hot deserts to icy polar regions. These temperature differences drive atmospheric circulation patterns. The movement of air masses around the planet is a key component in weather formation. Warm air rises at the equator and flows towards the poles, creating a cycle of air movement known as convection currents. Cooler air sinks at the poles and flows towards the equator, completing the cycle and contributing to global wind patterns. This circulation of air creates wind, which can vary from gentle breezes to powerful storms, depending on the temperature differences and other factors. It also influences the distribution of precipitation. Areas where warm and cold air masses meet often experience significant weather events, such as rain, snow, and storms. The sun's energy also drives ocean currents. These currents are like rivers within the ocean, moving vast amounts of water and heat around the globe. These currents transport heat around the globe, affecting coastal climates and marine life. For example, the Gulf Stream carries warm water from the Gulf of Mexico up the eastern coast of the United States and across the Atlantic Ocean. They play a major role in regulating Earth's climate, helping to moderate temperatures and distribute heat more evenly across the planet. The sun is the primary driver of Earth's weather and climate systems. Its energy fuels the dynamic processes that shape our environment, making life on Earth possible.
Photosynthesis, powered by the sun. This incredible process is the foundation of life on our planet. Photosynthesis is one of the most important processes on Earth. It is the way plants harness the power of the sun to create energy. It's how plants convert sunlight into energy. This energy is crucial for their growth and development. Plants use chlorophyll to capture sunlight. Chlorophyll is the key to this energy conversion. Chlorophyll is a green pigment found in plant cells. It gives plants their vibrant green color. It absorbs light energy from the sun. This absorbed light energy is then used in the photosynthesis process. Plants use this energy to convert carbon dioxide and water into glucose. Glucose is a simple sugar that serves as a vital source of energy. Glucose is a type of sugar that plants use for food. It fuels their growth and allows them to thrive. This process releases oxygen as a byproduct. Oxygen is essential for the survival of most living organisms. Photosynthesis is essential for life on Earth. Without it, the planet would be barren and lifeless. It provides the oxygen we breathe. Every breath we take is a gift from the plants. It also forms the base of the food chain. Plants are the primary producers that support all other life forms. All living things ultimately depend on photosynthesis for their survival. From the tiniest insects to the largest mammals, every creature relies on this process to sustain life.
Mercury, a scorched world. Mercury is the smallest planet in our solar system. It's also the closest planet to the Sun. Mercury is a rocky planet with a very thin atmosphere. Because it's so close to the Sun, Mercury is extremely hot. Temperatures on Mercury can reach 800 degrees Fahrenheit or 430 degrees Celsius. Mercury has a very slow rotation. It takes Mercury 59 Earth days to rotate once on its axis. It takes Mercury 88 Earth days to orbit the Sun once. This means that a day on Mercury is longer than a year on Mercury.
Venus is often called Earth's twin. That's because Venus is similar in size and composition to Earth. But Venus is a very different place from our planet. Venus has a thick, toxic atmosphere. This atmosphere traps heat, making Venus the hottest planet in our solar system. Temperatures on Venus can reach 900 degrees Fahrenheit or 475 degrees Celsius. Venus also rotates very slowly. It rotates in the opposite direction of most planets. A day on Venus is longer than a year on Venus.
Earth is a very special planet. It's the only planet in our solar system known to support life. Earth is the third planet from the Sun. It's located in what's called the habitable zone. The habitable zone is the region around a star where conditions are just right for liquid water to exist on a planet's surface. Liquid water is essential for life as we know it. Earth has a unique atmosphere that protects us from harmful radiation from the Sun. It also helps regulate our planet's temperature. Earth is a truly remarkable planet. It's a testament to the delicate balance of conditions needed for life to thrive.
Mars has always captured our imagination. It's the fourth planet from the Sun. Mars is known as the red planet because of its reddish appearance. This is due to iron oxide or rust on its surface. Mars is a cold, desert-like planet with a very thin atmosphere. But there is evidence that Mars was once much warmer and wetter. Scientists believe that Mars may have once had oceans and rivers. Today, we send rovers to Mars to explore its surface and search for signs of past or present life.
Beyond Mars lie the gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets are much larger than the inner rocky planets. They are made mostly of gas and ice. Jupiter is the largest planet in our solar system. It's a giant ball of swirling gas. Saturn is famous for its stunning rings. These rings are made up of ice and rock particles. Uranus and Neptune are ice giants. They are located in the outer reaches of our solar system. These distant worlds are still shrouded in mystery, but they continue to fascinate us with their beauty and intrigue.